Welcome students to another Method Man episode. Today we'll be graphing piecewise functions, so you're probably here to figure out the easiest way to do this, and I'm gonna give you that. What is a piecewise function? First of all, I'm just gonna try to put this in my own words. It might not be right, but this is the way I'm gonna explain it. Piecewise function are multiple functions within a graph. This one has two, where you only graph each function with the given interval. So for 3x plus 5, I'm only going to graph the parts where x is less than or equal to -2. And for x minus 4, I'm only going to graph the part where x is more than 2 for that part. Easiest way to do this is to graph each equation one by one, then erase the part of the graph that's not included within the interval. So you will probably need a pencil and an eraser. When you're first graphing, graph your first function really lightly because you're going to have to erase some parts of it. So we'll start with this one, 3x plus 5. That's already in slope-intercept form, so that means that I'm starting at 5, and then I follow my slope. Go up 3 over 1, and make your line. Next, you look at the interval for 3x plus 5, and then you erase the parts that's not included with it. So this is saying that I only graphed the equation in red for the parts where x is less than or equal to -2. -2 is right here, and everything less than that is to the left of it. Anything from -2 and up, I'm going to erase that part of the graph. Told you need an eraser. Since this set is saying that it could equal -2, I'm going to put a darkened circle right there. So I'm halfway done with my problem. All I have to do is graph the next function, x minus 4. Second function says start at -4 with a slope of 1, so that means up 1 over 1, just like that. Now I do the same thing. I take a look at the interval for x minus 4. This is saying that it's got to be greater than 2. So I take a look at 2, and anything greater than that is what I'm going to keep. Anything that's not within that interval, I'm going to erase. I'm going to keep all that part. Everything else I'm going to erase. Just like that. Since this is saying that it has to be more than 2, I'm going to leave this open circle right here, meaning it can't be defined at 2, but anything greater than that, the graph I'm going to keep. In this example, it's a little different because you're graphing 3 functions. Try out the problem on your own and take out a piece of graph paper. Remember, do this in pencil so that way you can erase all the parts that's not included in the interval within each function. When you are done, check the answers on the next page. Alright, here are your answers. We'll start with the first function, 2x minus 1. I graphed the whole thing at first, and then I erased all the parts where it's not included within the interval. The next one is just saying graph f of x equals 4, so it's just a straight line through 4. Then I only keep the parts that is in between -2 to 3. Open circle right here because this doesn't have an equal sign under it. Closed circle right there because this one has the equal sign under it. Then the last part, I graph -x plus 2, and then I erased all the parts that does not suit this interval right here. Open circle again, because that doesn't have an equal sign under it. These are annoying at first, but once you get the hang of it, they're actually pretty easy. It's like graphing 3 graphs in one graph, and then just erasing the parts by following the intervals that it gives you. Hopefully that made sense. I tried to explain it as easy as I can. And if you like this lesson, then check out my other lessons to help you with your algebra class. Until then, I will see you on the next episode. Peace.